Hi guys, it's Professor Walker Waugh, and I'm here to talk to you about balancing reactions. I'm going to try to keep it short, so you guys text me and let me know how well it goes. The only problem is sometimes it doesn't flip between the screens, but we've got the next one up. Now, when you're balancing reactions, I want you to remember that the law of conservation of mass. Matter cannot be created nor destroyed. So I want you to use common sense. However many atoms you start off with on the reactant side, that's the left side, I want you to have that also be on the product side. So let's get a method. I think that'll help you out a lot. So this is number one thing. Let's see if I can make this cursor thing moving. Uh-oh. Oh, look. Oh my God, I can draw and zoom. Okay. I don't know what that is. Okay, anyway. The method is really straightforward. Okay? You're going to treat all of the polyatomic ions as one unit if it does not change from the reactant side to the product side of the equation. If you see sulfate, SO4, 2- in some kind of reaction on the reactant side, you better have the SO4, 2- with something else on the product side. If it does not change, then you keep it. Then you're going to balance all of your non-hydrogens and oxygen atoms. That means your carbons, your nitrogens, whatever else that's there. Then you're going to balance those hydrogen atoms. And last but not least, balance those horrible oxygen atoms. They can really mess with you. And then you check yourself before you wreck yourself. Moving right along. Uh-oh. There we go. Simple things to watch out for when balancing reactions. Remember, you can only change the coefficient, but not the subscripts. Okay? If you change the subscripts, you're saying to me that you are God. And you cannot do that, okay? Combustion reactions means that when a substance is burned, it reacts with oxygen gas. Now, I am not going to tell you that it reacts with oxygen gas. The only thing I'm going to say is methane burns. That's the only thing I say. I know you know the formula of methane. And so I know that you know to say CH4 gas plus O2 gas forms. All right? Because I'm not giving that to you. Oxygen must be present for something to burn. It supports combustion. And don't forget, whenever you get the odd number of oxygen atoms on the product side, you better check it before you wreck it. We're going to go back and look at some things in just a moment where I do just that. I want you to pay attention. Last but not least, remember that oxygen atoms, the oxygen atoms sometimes will be in the substance that you're going to burn. So be careful with that because, you know, I love to do that kind of mean stuff to you. Make sure you pay attention and follow the same things that we discussed earlier. Now, the balancing pitfalls. All right. Again, this is what I just mentioned. Oxygen atoms sometimes it would be an odd number on the product side. I always love doing this thing with butane. It says butane gas burns. Okay, I'll give you the formula of butane because I know you don't know that. And I'll tell you it's a gas. I need the states there as well, but mostly on the product side because when I grade, I will only grade the product side. And you know, as I just mentioned, if I said something burns, you are to react it with oxygen gas. And you will produce carbon dioxide gas plus water vapor. Now, I'm going to promise you to always give you an excess amount of oxygen gas. That means more oxygen gas than you will ever need. And then you're going to make sure that you know that if a hydrocarbon, carbon and hydrogen only in the reactant, or hydrocarbon plus oxygen, then you are going to always produce carbon dioxide gas and water vapor. not water liquid. If I see water liquid on the product side, I will give you a 0. You will not be my hero. Now, let's look at this. Again, following the rules, I don't have any polyatomic ions, so I don't have to stress. But then the first thing you're going to do is balance your non-hydrogen and oxygen atoms. The only thing I had was carbon. So 4 carbons on the reactant side. I put a 4 in front of carbon dioxide on the product side. Then I'm going to balance my hydrogens. I say, oh, I've got 10, 1 as the coefficient of butane times the 10 down there behind the subscript of hydrogen. That gives me 10 hydrogen atoms. On the product side, if I put a 5 in front of water, I will now have 10 hydrogen atoms on the product side, because 5 times 2 is 10. And remember, we don't write ones in chemistry. Then you're going to balance your oxygen atoms. Initially, I had 2 oxygen atoms, but on the product side, I have a total of 13 oxygen atoms. So I'm going to make a fraction. And 13 over 2 times 2, that subscript, which you do not touch, is equal to 13. So what we have to do is to get rid of that fraction. That 13 over 2 we're not going to leave. In order to do that, we will multiply the entire equation by 2 to remove that fraction. So 2 times the coefficient of 1, that is in front of butane, is 2. 13 over 2 times 2 is 13 oxygen molecules. 4 times 2 is 8 carbon dioxide molecules. 5 times 2 is 10 water molecules. Then we checked it, and guess what? We did not wreck it. The other balancing pitfall that we have is when I put that oxygen inside of the reactant that is burning. Notice, ooh, that can be pretty hairy. Do the same thing as we did before. So I balance my carbon, 1 carbon on the reactant side, 1 carbon on the product side. Then I look at my hydrogen atoms. I have a total of 4 on the reactant side. So to balance it, I have to put a 2 in front of the water molecule, because 2 times 2 is 4 for the hydrogen atoms. But I cannot leave that odd number then. Check it out. I've got 4 oxygens on the product side total and only 3 on the reactant side of this equation. So I make a fraction. I do not want to touch the oxygen in the methanol. That's CH3OH. So what I do is I make a fraction, 3 over 2, for my water molecules. And we know now that would balance it with a total of 4 oxygens on the reactant side and 4 oxygens on the product side. So, again, multiply the entire equation by 2 to remove that fraction. And we check it, and we have not wrecked it. Okay, this concludes my very first recording for YouTube. And let's see how it sounds. And I'm going to publish this and give you guys the location. Have a great day and listen up, because the next thing I'm going to do is your double displacement reactions.